Well, hello again. It is after the first of the year. I hope everybody had a great New Year's Eve. I just stayed at home. I was tired. Christmas wore me out. And I decided, I got some time. I'm a little more energetic here. I got a little time. I want to do some other things today, but let's do a little bit of this. I'd like to be able to isolate down Kurt Eicherman, the one I mentioned in the last video. He said, John, before you do anything, you're going to have to find out where that short is. He's right. I knew that. Brendan's been telling me that all along. And I was kind of thinking it was just something in here. But I have had time to think about it. It could be a short between this coil and this one, or this one and this one. Or I guess, I don't know, it could even be a short between all three, for all I know. Because whatever went on in that transformer went on, and I don't know what it was. And, this second half here is burned. It could be I got a problem with the speaker field coil right here. It ohms out okay, but I don't know. I know it's not the electrolytics. I put brand new ones in. And that could be why the person before me put new ones in, because it started, wiped out transformer. So he didn't probably think it was here. He just probably thought it was here. Might have blown one of them up for all I know. I don't know. So what we're going to do, we're going to find out, I'm going to do my best to kind of isolate things. We're going to go ahead, and I've got all the tubes out of the radio. We're going to put the 80 tube rectifier back in, and then we're going to bring it up. First I'm going to bring it up with no tubes at all. Then we'll put the 80 in, turn it on, and bring it up there. If everything's normal, then we'll go ahead and pull the 80 out, and we'll put all the remaining 3 tubes in, one at a time, and see what happens with the filament winding. I don't know if that makes much sense to everybody. It doesn't make a whole lot to me. But let's test it first with no tubes in it. Alright, what I'm going to do is just go ahead and turn this baby on first. Just crank it on up. And we'll apply some power with the Variac. Get this lamp out of my way a little bit. And now we'll just go ahead and crank up the voltage. Well, we're up to 20, nothing's happening. 30, 40, 60, okay, we're up to 80 volts, nothing's happening, that's good. Whereas before, just at 20, like I said, it would peg all the way out. So we can go ahead and shut it off, and let's put the 80 tube in there and see what happens. Our rectifier tube is now in, and for those of you who may have just chimed in for the first time trying to figure out what I'm talking about, we have a short here. The high voltage winding on the original transformer, which is the one sitting on the chassis right now. I've taken the clamshell off the top. It's blown out here in the bottom, this bottom part of the winding, and I am powering the high voltage winding with this transformer over here. I just wired it in with the 3 wires that go here, okay? 1, 2, and 3. So the original transformer is still powering the filament for the rectifier, and it's still powering the filaments to the remaining 3 tubes. So if this should light up the tube, the rectifier, the way it is right now, is the way it's plugged in, because the one I have plugged in is this one here right now. So we'll see what happens. Maybe we can get that thing to light up, I hope, without pegging out our meter. Let's try it again. Alright, here we go. There's 20 volts, 30, 40, 50, 60. Let's give it a couple seconds. I don't want it to peg out on me instantaneously and wipe something else out. Let's go a little bit higher. Let's just take it up to 80, around 85. Nothing's happening so far. Turn the light off, see if she's lighting up. It should be. I mean, we're drawing current. Yeah, okay. Okay, the rectifier's lighting up. Alright, well, we're doing pretty good so far. Alright, I'm happy. It's not pegging out. Let's go up a little farther. Let's just take it up to 100 volts, see what happens. Now that I like. Now that's really what the rest of the radio should normally draw on an everyday deal, with not being broken the way it is. Our 6A7 is in, and I'm not even going to hook up the cap. We're just going to do that first, then we'll hook up the cap if everything's fairly normal here. Let's bring it up now, see what happens. Do I still have it on? Yes, I do. All right, here goes. I'm just trying to isolate it down. $50, $60. We're doing real well. Let me make sure it's not lighting up too. I think it's barely lighting up. Let me take it up a little bit more. Take it up to about 80 volts. Yes, she's lighting up. See ya? All right. Not bad. Now let's go ahead and hook up our cap and see if that makes any difference. We're still sitting at 80. It's a slow, tedious process, guys. You know, you just got to take your time. This is just going to get us into a section, I hope, and then of course we're going to have to start all over again troubleshooting that one section. Okay, I'd say that's good. Let me remove that tube and put the next one in, which will be a 6C6 in place of the 77, which was original to the radio. It's down in there. The original, the 77 was original right there. You can see it. Again, I'll hook the cap up to it after I test it first with just the tube, the 6C6. Let's take it up. I'm watching the. I'm over here watching the voltmeter, by the way, for those of you who may have never tuned into my channel before. We are up to 40 volts. So far, it's looking real good. 60 volts. 80. Well, if she's not pegging out by 80, we'll just go ahead and say it's good. Let me make sure the tube's lit up. Yes, the tube is lit up. Let's go ahead and hook this back up, see if it makes any difference. So I'm going to push it on there. We're up to 80 volts and still no short. Fantastic. Let's move on to the next one, which will be the 42 tube. Alright, this is the last of the Mohegans as far as the tubes go. Let's see what happens here. We'll crank it up here, see what's going on here. We're up to 30, 40, 50, 60. Nothing happening on the ammeter. 80. Yes, and the tube's lighting up. I can see it right from here. Well, now let's do a reevaluation on the schematic. Well, I think the results of that pretty much shoot one of my theories down, that it would be a shorted rectifier filament coil, or the remaining tube heater coil would be shorted. So both of those have now passed the test. Now what I'm going to do is I'm going to unplug the power cord on the radio, and I'm going to plug in our secondary transformer that I have wired in to the high voltage winding and see what happens. You know, it's going to be interesting. Alrighty, tighty. This ought to be fun. You watch, that thing will just peg right out as soon as I fire it up. I wish it wouldn't, but it probably will. Let's bring it on up. Slowly. Oh my goodness, look at there. I just barely touched it and she shorted. Look at that. Look at that. That's what I'm talking about. Alright, now we know something. I'm going to show you what I think next. Next, I have to determine whether or not the short is located actually in the coil here, or is it out here in the speaker field. Okay, I'm going to remove the center tap and find out if we still have our short. If we do, then that's pretty much cements it. That's the end of it. So let me remove the center tap that leads out to the speaker field coil. Now these were the existing 3 wires, the top and bottom of the high voltage coil, and this is the center tap. And I've replaced them with these 3 here out of this transformer, which means I got to plug it in separately. Anyway, I made sure the center tap wire was orange, and I just tacked everything on. I didn't do a heavy weld, or heavy solder rather. And I'm going to just unsolder this here, and then we'll see if we still have our short. Alright, as a quick reminder, I disconnected this wire right here that runs out to the field coil, goes up through the chassis from the transformer, and ran up through a hole in the chassis and connected to the field coil on top where the speaker's at. So it's no longer there. I disconnected it. It's just hanging out here in the wind. Okay, here goes. Let's zoom in on here so you can watch this. Hopefully, let me see, I'm at 0 right now. Oh my goodness, look at that. Look at that. I'll tell you what, guys. One thing about working on these old radios is you never make an assumption when you're troubleshooting. You've got to be able to prove it. Don't make an assumption. You know, you can make guesses, but assumptions, they always seem to go wrong. And what I decided, you know, based on that experience and thought, I decided I would take loose one of the plate wires to the transformer, which means one of these plate wires is off. I think it's number, let me see, 1, 2, number 2. I guess that's this one here. I'm not sure which is which on the schematic, but I have this thing, the plate, completely out of the circuit now, which then I've got it taped up. This was just one of those, you know, let's try it things, you know. So then I went ahead and I powered up the radio and watch what happens with nothing connected to the plate to the plates on the rectifier. Bring it up. Look at that. Look at that. Oop. Well, that's not cool. Let's disconnect the other plate wire. Alright, I've got the entire thing out of the circuit now. Let's go ahead and fire it up again and see what happens. It's still plugged in. Close this box here a little bit. I got to do something about the latch on that box. It's not working so hot. Anyway, nothing is connected to the radio. Now let's go ahead and turn it up and see what we get. Okay, people, I think I know the problem. It's not in the radio. The problem is this transformer is no good either. I think the primary might be bad. Oh, is that terrible or is that terrible? Something's not right there. We've been chasing a ghost in here when in fact it's not even connected, but yet we're getting very high current. She has been opened up like a can here now, and this one here, it's kind of interesting. This one is fairly loose. Let me get over here where you can get a better look here. See that black wire down in there? Zoom in here. It's tarnish is what it is on the wire, but no, it's very loose. But it's not having any effect on the resistance reading. So what we're going to do, we're going to hook this back up to the variac and see if we still get a short. In case some of you were wondering, I use this real small X-Acto knife to cut it open. Okay, I have a box of them I bought quite a while ago. It's got a whole bunch of blades and 3 different handles, and I can't remember where I got it. I might have got it at Hobby Lobby. I can't remember. Anyway, I cut it open. That's what I used. Secondly, in case some of you were wondering, I did a continuity check between these wires and all the rest, and also the laminations and the screw here. No continuity anywhere. So I don't know. I mean, you know, except through these windings here, of course. All right, I've got it. I got it all hooked up. You'll notice I taped everything again. Any connection that's bare of any kind, tape them up, insulate them. Even the ones where you connect into the transformer. Safety first, guys. Safety first. You want to go to work the next day, right? You want to get out of bed the next day, right? Yeah, well, safety first, okay? If you're unsure, do it. Save, you know, if you don't know if you should tape this one off, do it. Don't worry about it. How much does it cost for an 1.5 inches, 2 inches of tape? Alright, let's see what we got here. I got the variac is down, power's on. Oh, come on, guys, do me a favor and just don't go up like you were. Yeah, look at that. Alright, well, there's some kind of short down inside there. It's breaking down. I don't get it. I just do not get it at all. Some of you might also be wondering, well, maybe it's the Variac that's doing this. Maybe it's the ammeter's bad or something like that. Well, it's not, because I've got this radio here plugged in to the same place, and you'll notice that the current draw is less than 200 milliamps, and it sounds good.
Defense from just a personnel standpoint, we didn't know how they would perform.
Okay, solves that question too. Well, I figured with nothing to lose, what the heck, let's just peel it all back and see what it looks like so I can show you guys. This is some pretty stout wire. This is really thick wire for the primary. Most of the wires aren't quite that thick, but I don't know. Maybe this is some kind of special weird transformer that's supposed to draw that kind of current. I don't know. What do I know? I don't even know what it's from. He didn't know what it was from. But this is your primary. I'll turn it around here so you can see the wires going in. One wire goes in there and it comes out the bottom down here. And then the rest of it's down below in here. Well, I guess this is it. We're not going to pursue this much longer. We'll go back to using the transformer that's currently in the radio and see if we can't set up that voltage doubler setup. And we'll try it probably both ways, 2 different ways. See if we can't get it to go. So this thing is going in the old trasharoo. Last but not least, it seems to me that this old radio just is going to fight me every step of the way. It does not want to be repaired. Well, I got news for it. It will bend to my will. The last little effort it put in, trying to stop me and stop us, is the 42 tube got dropped on the floor and broke all the pieces. Go ahead, try as you may, radio. You will not win this battle. Until next time, this is John.